Hello everyone, my name is Mohit Saini and I am going to present on temperature transducers. First, we start with introduction that what is a transducer? Transducer is a device that converts one form of energy into another form of energy. As you can see here, this is a basic block diagram of a transducer, which consists of a sensor. The sensor takes in an input and converts it into an output, which acts as an input to the signal conditioning unit or the transduction unit. The transduction unit then produces an output which is in a suitable electrical form that can be measured. Now, the temperature transducers are used to measure the temperature of an object. The two major components of a temperature transducer are sensing element and the transduction element. The sensing element has some property that changes with temperature. Therefore, it should have high sensitivity, it should have high resistivity, and there should be a continuous relationship of the sensing element with the temperature. The transduction element converts the output of the sensing element into suitable electrical quantity, and this output which comes out of the signal conditioning unit or the transduction unit can be calibrated to measure the temperature change or the temperature of an object. Now, what are the types of temperature transducers? Generally, they are divided into two types. First is contact type transducer, and second is non-contact type temperature transducers. As the name suggests, contact type transducers are those temperature transducers in which the sensing element is in direct contact with the body whose temperature is to be measured. And in non-contact type transducers, the sensing element of the temperature transducer is not in direct contact with the body whose temperature is to be measured. So in case of contact type transducer, conduction is the basic phenomena to transfer the thermal energy from the body to the sensing element. And in non-contact type temperature transducers, convection is the basic phenomena through which the thermal energy gets transferred from the object to the sensing element. Now, based on the structure and function of the transducers, temperature transducers can be categorized into mainly four categories. First one is thermistor, then resistance thermometers, then thermocouples, and integrated circuit temperature transducers. First, we talk about thermistor. As the name suggests, thermistor is made up of two words, which is thermal and resistor. So it is a resistance that varies with temperature. Uh, the major benefit of using a thermistor is that it has high resolution. We can measure very small temperature changes with the help of thermistor. A thermistor is made up of metallic oxides, binders, and stabilizers, and they are pressed into wafers and then cut into chip sizes. As you can see here, there are three types of thermistors that are shown here. One is the disc thermistor, other one is the bead thermistor, and the third one is the rod thermistor. Uh, Thermistors are broadly categorized into two types. One is the negative temperature coefficient thermistor, and the other one is positive temperature coefficient thermistors. In negative temperature coefficient thermistors, the resistance of the thermistor decreases with the increase in temperature, and in case of positive temperature coefficient thermistors, the resistance of the thermistor increases with the increase in temperature. NTC thermistors are basically used for temperature measurement, while PTC thermistors are primarily used for circuit protection. If we want to use thermistor in the low temperature range, which is minus 25 degrees Celsius to approximately 70 degrees Celsius, then we use thermistors which have low resistance in the range of 2 to 5 ohms to 10,000 ohms. If we want to measure higher temperatures, then we go for higher resistance thermistors. The thermistors are accurate to approximately plus minus 0.2 degrees Celsius, which is quite accurate. As you can see here, these are the resistance versus temperature diagrams for NTC and PTC thermistors. The resistance decreases with increase in temperature for NTC thermistor, and resistance increases with increase in temperature with PTC thermistor. The main advantage of using thermistors is that they are generally durable, they are long lasting, and they are inexpensive. Thermistors that have epoxy coatings, they are available to use at lower temperatures. And the working range of thermistors is basically between 0 degrees Celsius to 100 degrees Celsius. Thermistors are chemically stable and their accuracy does not change significantly with age. The uses of thermistors, some uses of thermistors are given as follows. As current limiting devices, they are used in circuit security and they are used as replacement for using in various circuits. They are used as circuit protectors in lithium batteries. Also in various appliances that we use in our daily lives, they are used to control the temperature of those devices. For example, toasters, freezers, refrigerators, and hair dryers. Now we move on to resistance thermometers, also known as resistance temperature detectors or RTDs. These are relatively high accuracy temperature sensors and they are made up of high purity conducting metals such as copper, platinum, or nickel, and these metals are bound into a coil, as you can see here. The RTD value is measured using a bridge circuit. As you can see here, this is a two-wire RTD, and the RTD value is measured using a bridge circuit with the help of a constant voltage supply. The main advantage of RTD is that it has better stability than other temperature transducers at higher temperatures, and the range in which it can measure the temperature is minus 182.96 degrees Celsius to 630.74 degrees Celsius. And the output that we get from the RTD value, it can be calibrated to measure the temperature change or the temperature of an object. The main disadvantage is that in industrial applications, RTDs cannot be used above 660 degrees Celsius because it becomes very difficult to protect the platinum or the metal from which RTD is made from becoming contaminated by impurities. The other disadvantage is that it is expensive than other temperature transducers. Now coming to the classification of RTDs in terms of wiring configurations, these are classified into three types: 2-wire, 3-wire, and 4-wire. Now we talk about thermocouples. Thermocouples consist of two junctions of different metals, such as constant tin and copper, and they are welded together. One of the junction is a hot junction and other one is the cold junction, as you can see here. And the temperature difference between the two junctions lead to a development of potential difference across the two junctions, which is known as Seebeck effect. A vast temperature range uh, is offered by thermocouples compared to RTDs and thermistors. As you can see here, the temperature range is minus 200 degrees Celsius to 2000 degrees Celsius. And the other benefits include they are active transducers as they do not require any external power supply to operate. They are more affordable than thermistors and RTDs, but they have lower accuracy compared to thermistors and RTDs, which is a drawback. Now, the types of thermocouples. Thermocouples are divided into several categories based on the metals that is used uh, in constructing the thermocouple and also on the sensitivity of the thermocouple. If we use nickel alloy thermocouples, then they are classified into types E, J, K, M, N, and T. If we use platinum rhodium alloy thermocouples, then the types are B, R, S. These are the least sensitive thermocouples available. Then we have tungsten rhenium alloy thermocouples, which are classified into types C, D, and G. Now the applications that involved thermocouples are measurement for temperature measurement for furnaces, diesel engines, and they are used in manufacturing processes and fog devices also. Now, the last one that we need to talk about is integrated circuit temperature transducers. They employ the temperature sensing component with solid electronic circuit as a combination for temperature measurement. The integrated circuit temperature transducer, shortly known as ICT, it is a two-terminal monolithic integrated circuit whose output is a current or voltage, and that output is directly proportional to the temperature. The main thing that happens in integrated circuit transducer is that there is a silicon transistor whose base emitter voltage varies with temperature, and this voltage is calculated and then calibrated to measure the temperature. The main advantage is that they are linear temperature transducers and they are very affordable. The major drawback of IC transducers are they have a very tiny operating range that is only between 0 to 200 degrees Celsius, and which is their primary drawback. Now, they are used to sense the temperature of a printed circuit board and the ambient air around it. They are used to measure the temperature of PCs so that they can control the temperature of PCs. Also, they are used as simple fan controllers because it can sense the temperature and then control the speed of the fan. So that's all from my side. Thank you.